And if you would have overwritten this one over that one, you could have gone back.
Oh, okay.
You got to work on the one page. Simple, quick, stuff that's obviously repetitiously stupid.
Okay, again, I keep showing attendance because I want someone to let me know if I'm counting someone absent that's here somewhere. I know, oh, there's Isaac. Isaac is here, let's see who else. Okay. That's it. Getting there, getting there. Okay, good morning, everybody. Yay, it's happy Monday. I love how you guys all move. We have people over here, people everywhere. We're starting on chapter 8. We're moving our way back because we were on chapter 14 last week. So we're going to be looking at working with interfaces, which are a special kind of class that may admit similar people. Before we get started, though, we have a lot going on. Today we're going to look at the interfaces, and of course that last little assignment is kind of waiting for that information. If you've gone ahead and read ahead, that's good too, trying to work that out. Interfaces is definitely a topic where if you Google it and you look online, you're going to find a million different explanations or examples. So it's kind of a wide open topic where you can find a lot of things. So we'll focus on what our textbook presents. Wednesday, we have our guest speakers from Jack Henry. And so they'll be on Zoom session, and I haven't nailed down with them exactly. We'll probably start about 8, 10, around in there, give everybody a chance to get settled in and all that stuff. And I don't know if they'll probably be at home, because both of them usually work from home before the pandemic anyway. So they'll probably both be at home. So how long of class we use for our guest speakers will just depend on how much time you guys need. Sometimes they're more talkative than other days, and sometimes you guys are more talkative. So be sure to ask them as many questions as you can. These two are both really, really good resources, people to have like connections to that you can email and say, hey, I'm ready to find an internship. Do you still have that internship open, and things like that. So those are good things. Now, after our guest speakers, we'll do our sports team code walkthroughs, but those will definitely be secondary to our guest speakers. So I don't want you guys to be really focused, worried about those, kind of put those on the back burner. We want to see what the guest speakers have to say, and then we'll spend a few minutes after they're done looking at those sports teams set up. They should be pretty similar to each other, right? We don't have a lot of great variation here setting up our sports teams. Some people had some really good ideas though. Friday evening at midnight, your Unit 1 exam is due. And Monday morning, we'll have our Unit 1 hands-on presentation. So let's look at that before we get started on our interface stuff too. So you can see why I'm not as concerned about our sports team stuff. So our hands-on for Unit 1 is going to use the same kind of picture box idea as our puddles around the rose assignment. And you can change this up however you like, use your own design ideas. We basically want something that's like a slot machine app. So the requirements here are that we have to use class definitions. We have to have like at least 10 different images that are possible to be displayed. And if we randomly are awarded 2 of a kind, we would add 10 cents to this credit. And if they're awarded 3 of a kind, we would add $1 to this credit. You can determine how you want to handle the credit, totally up to you.
Me and Isaac can't see the screen.
Well, let me share it. How would that be? That's probably what someone online is saying too. Can't see a thing, woman.
Thank you.
Thank you. Yep. Isaac didn't see a screen either. Sorry, Isaac. Okay. So we wanted to just be a little slot machine. In this one, you can see they just have a play button. You can set it up, like I said, however you would like for it to work. Sorry, I'm all steaming up. So really, when you look at the screen, this is like in no way what you have to do. So yours can look completely different. You can do it however you like. You just need to have at least 10 images that are randomly displayed and some classes. So, whatever kind of awesome thing you want to create. Do it. All the freedom. Okay, I keep admitting people. Admit, admit, admit. Questions about that one?
No questions other than that was my project for the last class. And I actually have it pulled up here and thought that would be cheating.
Oh,
If I actually had that assignment. So
that's nice. What language is it?
C#.
Oh, well, shoot.
Okay.
You're going to have to decide what you want to do. You'll be right now. Oh, it's very fancy, though.
I'm going to make it better than I'll take Artie's advice.
Good, make it
I
better.
would tell you that was an unfair advantage.
That's awesome. If you notice, I want your .cs files uploaded to Canvas. And if you look in your grades, you guys might have to do some digging to find the comments I leave on your .cs file, Gary was showing me, Richard, I'm sorry, I never see what it looks like to be a student. And so when I leave those comments on the code, to me, that's like the most visible place, but it's a little hidden for you guys. So you have to actually like click on the assignment in your grades and then see, what does it say, annotation?
No, it says view something.
Do something, that's that.
Do something.
Do something, that's that word I can never think of, and I can't, it won't show me.
I'll find it here.
You guys are so good, I don't even know what it says.
It was under grades, and then you can go to grades, and you go to the little deal.
So you'll only have little comments there if maybe if I took points off.
And then there's a little icon to the right. Click on it. Oh, no, you click on the actual assignment, LO3 sports teams class def, and then in there it says view feedback.
Feedback. Sorry, it's so buried.
And then it tells you why you missed a point.
It's like, if you want to know why you missed that point, you have to really work to find out, and that's not what I intend at all. It's just so much easier when it's right on your code, and I can say, what about this? So I think that there's not a lot of comments on our code this time, because your classes were pretty linear. Such cool stuff, though. Everybody did a really good job. The classes are all looking excellent. Now, on your Unit 1 exam, I was also giving Richard a hard time saying, no, there's nothing to help you prepare. I lied a little bit, sort of. There is this MTA study guide on Quizlet, and I can tell you that every question on your test was probably in this. You have to click on the link up here maybe to get it to open. So that first screen where it's giving you the sad face, just keep going past the sad face. So the problem is there are like 83 cards in this deck, but it's a really good MTA study deck. So I don't want you to go crazy about that. What I was telling Richard is you guys are going to know the answers to these questions or not. I mean, right now. So from the code that we've done, that's going to be enough experience to be able to answer the majority of the questions. So think of this exam as kind of a preliminary preview of what your certification exam will be on down the road, and just note to yourself the things that are totally foreign to you that we need to work on and get fixed. So there's 15 questions. It's a very short test, but each of the questions are kind of can be a little wordy, like the actual exam. Bless you. So it's not a practice test, but it's a huge amount of information, I guess. All right, so let's look at interfaces.
Need to get into the gym session.
I just let him in.
Oh, okay. Well,
Is he getting knocked out or something? I wonder if he's having some sort of trouble. I think he's in. Thank you. I think he's in, but I think he's having some sort of issue. So thank you guys for watching him. Okay, I think I got you guys. No carrots, tell. Save. All right, so we're looking at our Unit 1 exam, and I sneaked in there a PowerPoint on interfaces. So that's the one we're going to look at if you want to grab it. I'm still looking for a clicky thing. I will find one before our semester's over. Isaac, can you hear me? I think you can hear me. Okay, good, thanks. This little round thing, I think I pushed a button on it the other day and it went wacko. Okay, interfaces. This is a hard one for me because there's this term, GUI, graphical user interface. And to me, that's what an interface is my user interface. The user sees the interface, right? That's not what this is. This is an opportunity for us to see where our field has used the same exact term to mean something completely different. Yay. So what have we done? We've changed the graphical user interface now to be the UX, the user experience. So that way it doesn't overlap with this term, which has nothing to do with a user's experience at all, but it has to do with C# code and how we organize our code. So an interface, when we're working with a C# code interface, is just a set of abstract members. And that'll mean more, hopefully, in a little bit. So an abstract member is something that doesn't provide a default implementation. We worked with one of those last week. The abstract member that we worked with was our abstract method that we created. Remember, because when we say abstract method name, then we put our parameter list and then a semicolon, we didn't have a body. Right? So when we don't have a body, that means it does not provide a default implementation. It's abstract, right? So we didn't have any sort of body for that. So an interface is going to be a whole bunch of those, a whole bunch basically of abstract method declarations all together. So whenever we put these abstract method declarations together, we're going to put them together to express some sort of behavior. So we can have, with our classes, we can only inherit from one class. We can only extend one class in C#. But with interfaces, we can implement many, many interfaces. So we can share this kind of exposed behavior among several classes by using interfaces. Let's see what some things look like here. Here's a picture of some code that's out of our book. And they show this class named clonable type, and then inside here they have this abstract method definition without a default implementation, right? It has no body. Okay, so that's all we're talking about are those abstract method declarations. Now, here I have a class statement for a minivan, and it's from our textbook, and it shows that a minivan inherits from the car class. And then it's also wanting to inherit from this clonable type, but we can't do that. We can't have two basically parent classes. So what we can do instead is create an interface. Now this is an interface and it's a full definition. So instead of the word class, it says the word interface. And then our interface name usually starts with an I in C#. And if you notice, it's usually an uppercase I, and the rest of the class name kind of keeps our standard class name convention. So we start with an uppercase letter. And I mention that because we see a lot of weird interface names, and there is kind of a convention for that with C#. So here's my interface, and within my interface, I'm going to say, if you implement me as an interface, you must implement a method named clone. So that's all my interface does. It says anything that is part of this iClonable interface must implement a method named clone, and that method must return some sort of object. So my interface defines a behavior, basically just a method declaration. Now here's how I create an interface using Visual Studio. I'm going to have a project already going, and I'm already going to have some classes or whatever already in there, maybe, and then I'm going to add a new item, and I'm going to search for interface. And in the textbook, they really do have some really good examples. Whoops. One of being whether or not an object is pointy or not. So they set up this interface called iPointy, and then they have several objects that they're implementing here. A switchblade, four different things. All of the things that are sharp or pointy, they have implement the iPointy interface, because we could see that they would need whatever methods go along with objects being sharp. Here's an example of implementing that. We've got a circle here, and a circle is not necessarily pointy, so it is not part of the iPointy implementation. So what we can do is, in this case, they use a try-catch type logic, and they say, can C be cast as an iPointy? So notice an iPointy and interface can be used just like a class when we're trying to cast something. So we're saying, is C an iPointy? If not, we're going to throw this invalid cast exception error and run this catch code. But if it is, we're going to run this method that an iPointy object has called points. So we can use the as keyword, just like we were seeing last week with our class names. We could say, you know, is this a COVID patient? We can do that with our interfaces. In this example, they show us how we can use the as and is keywords. So I can set up a whole bunch of shapes here. In this example, I have an array of shapes, a hexagon, a circle, triangle, circle. And then I can look at each of those shapes and decide if that shape is implementing the iPointy interface using the is keyword, in the same way that we were looking at that stuff last week. If it is, then I know I can run the method that has to do with things being pointy. This picture gives us some nice class diagrams, and it shows us kind of the class hierarchy that they've created with their examples. They've created some different interfaces. So they've said we have these objects like circles and squares and hexagons and things, and many of them implement the iDrawable interface. We can draw them. If they implement the iDrawable interface, we'll see they're going to have to require a method called draw. We also have then the iPrintable interface, and if somebody implements this interface, they have to create a method called print. That's all those interfaces say, is if you implement me, you must create a method named print. Then other code that uses this code is going to know that it is something that can be printed, that does have a print method. Now the iShape interface is dependent upon both of them. How do we have it here? We have all of these things all working together. Our iShape interface implements the iDrawable and the iPrintable. So anything that's a shape is drawable and is printable. Looking at that class diagram, what I want you to notice here is that when we extend something, the arrowhead points to the base class or the base interface. We're used to, with flowcharts and things, the arrowhead pointing to the lesser object or the object that would be extended. But in our case, when we look at a class diagram, we're pointing back to a referring object, the object we're referring to. Here's another UML diagram that's, and again, this style is considered lollipop style, and it's what we see in Visual Studio when we say that we want to look at a class diagram. And of course, we saw we could use that to build our class. Now, the other thing that we're seeing here is the, the little circle. So that circle shows an implementation also. So I could say this rectangle class implements the iShape interface. Here's my iShape. My iShape implements the iDrawable and iPrintable interface. So a rectangle, because it implements the iShape interface now, is going to have a print method from the iPrint interface, a draw method from the iDrawable interface. So the rectangle is drawable and printable. If I look at a square here, it's the same. I have to have all of these. Why would I use an interface? These examples will show you a little bit of why. But I would use an interface in order to enforce code standards. So let's say, for example, in our application, we might have patients, COVID patients and maternity patients. But in our hospital, we might have all sorts of other entities in our database. And anytime that any of those entities gets changed within our database, we would like an audit report to be written, information to be written out to another place. Here is the original version of this database. Here's the updated version of this database. So in order to implement that, we could create an interface called, iAudit. Inside our interface, say that every method or every class that implements this iAudit interface has to have a method called log updates. And then we would know that any code we could look at in our shop should have this log updates method, and we would know how the updates for that database item get logged, because they would all be named the exact same, because they're all implementing the same interface that enforces that naming standard. So an interface gives us a way to encourage all of the developers to use the same method name for a certain method. Does that make sense? It's kind of a really cryptic idea. We'll have to look at some more. So here are some base net class libraries, predefined interfaces. And these ones will make a little bit more sense as we work with them. So in .NET, in the base classes, they have some interfaces that are already predefined for us. And we've used some of them without even thinking about it. One that we've used or implemented a lot is the foreach construct. Whenever we use a foreach construct, we're saying that we're using an IEnumerator type of collection. That means something that can be sorted, listed, numbered. That makes sense. So let's look at this garage over here. We have a bunch of cars. And we decided that on top of our car class, we want to create a garage class. And this garage class is going to have an array of cars, right? So here's Fifi and Clunker and Zippy and Fred. So in our constructor for our garage class, we've created this array of cars, right? So these are just car objects. We're the only ones that know what a car data type is, right? We've decided, we've created that class. We know a car data type has like the name of the car, and then I don't remember what that number is, like max speed or something. But anyhow, these are what our cars are. So the system, the C# system, will let us create that car class, but it doesn't really know that much about it. We've created that. So what if I want to be able to do a foreach command? I don't know if you can see this example. Let me try to make it a little bit smaller. Down here in the bottom, I've got my car lot that uses my garage class. It's going to have a whole array of cars. What I'd like to be able to do is say, hey, I want to allocate this variable I as all of those cars, that entire car array. I want it to be an IEnumerator. When I'm working with an enumerator or an enumerable interface, I have a move next method. So I could use that against my car IEnumerator. Then I could use other interfaces and methods that are available to the IEnumerator interface within my code. So the way that I would implement that is by adding the interface to my class statement. And then I would have to add a method named getEnumerator. That's going to be required. So as soon as I add IEnumerator to my class, now I have to add this method, getEnumerator. You know, it'll go to error. It'll make me do that. All I have to do then at that point is say, hey, IEnumerator is this array. So I'm saying my car array is what you can use as an enumeratable object. So now, over here in my code, when I say this variable I is my car lot getEnumerator, that's going to return that a car array to me, is an enumeratable object, and I'll be able to use the methods move, next, current, other things that go along with an IEnumerator, mostly the foreach. I would be able to say for each car in I, move through it. So the IEnumerator interface has gotten so far buried from us that we don't usually have to worry about it very much, because when we create an array, we can automatically use the foreach command with it, because C# takes care of that for us a little bit behind the scenes. Now, a couple of other things that we can do though when we're working with that you might run into code-wise. You could see a statement yield return. And if I'm using the yield return, that means that I'm going to process each object in that enumeratable list separately. So instead of returning the whole IEnumeratable list back to the caller as the enumerator, I'm going to return just one item. Now, the IComparable is another one that we use a lot, that we can implement to take more advantage of its capabilities within our classes. So let's look at this code here just for a second. I have a car, and I've said that my car is going to implement the IComparable interface. Whenever I implement the IComparable interface, I have to implement the compare_to method. The compare_to method then is going to help me decide whether this car is greater than or less than or equal to the car that it's asking me to compare to. So in my compare_to method, take a look at it here. First of all, this code is within my car class. Right? So in my car class, I already have a car instance, right? This is the car that I'm running that's working. But when I call my compare_to method, I'm going to be passing in another car instance, like the next one in the array, right? So I have this one that my car class is currently looking at, and then I have this object car that's being passed into my compare_to method. In my compare_to method, then I'm going to say, which car is greater? Is it this original car that's the instance of our class? Or is it this object car that's been passed into us? Now, it matters how I set the return value. And this is exactly the same in Java, so that's a nice thing. But here I'm saying, if the car ID of this car, the one that's current in our class, is greater than the car ID of the car that was passed in, return 1. The current car is greater, so it should sort higher. Next, if this car is less than the car ID I was passed, return a negative value. Otherwise, if they're the same, return 0. So this 0, -1, and +1 are expected by the sort method of our array class. So if we implement a compare_to method, all of a sudden we can sort an array of our objects in the way that we want to. So it's kind of way out there, kind of you can hear him talking, but we can implement it. So let's look at this car here before we go on. Here's our current car in our class, and here's the object car that was passed into our class, and we're just comparing the two of them to let the system know, well, according to my comparisons, the first car is greater. Because I might want to compare on all sorts of things. Maybe I want to sort my cars by color or by that number, that speed rating, or some other sort of weird sort thing. I can do that because if I implement a compare to method, and in my compare to method, I decide what I'm comparing to. Am I sorting by last name? Am I sorting by first name? Am I sorting by some number? So let's put a compare to in our application so we can see it implemented. Now, before we do that, an interface is very theoretical. So it's something that's kind of hard to get a grasp on, and that's a pretty advanced concept. So what you're going to be expected to be able to do is to understand that it's a named collection of abstract members, and you should be able to code one, interface name, pretty simple code, and then that method statement. But we want to understand behind the scenes that that behavior that we're implementing through that method then can be supported by all sorts of different types. Whatever class types want to implement our behavior can by implementing our interface. The interface helps us support interface-based polymorphism. So I can create these comparable objects no matter what they are. So no matter what I'm working with, frogs, toads, flowers, cars, whatever, I can make these into comparable objects by implementing that IComparable interface and saying, oh, in my compare to method, I say daisies are more important than roses. That's how I'm going to compare those two. So I can use polymorphism by treating all of these objects as something that can be compared to each other. Now, those system-defined interfaces, they give us a whole bunch of desirable traits, like enumerating, which I can't say, cloning, and sorting. So let's sort. We'll do that first, because I think that's a neat one for us to try. So let's open our Visual Studio project. And I hope everybody has it from last time. If there's anything that you need shared, let us know. And as I was looking at our project, I went to our patient tester, because that's where I want to be able to sort our data, right? And in our patient tester, we had this class we created, our database class, that just created our test data. And our test data was just this nice array, so it works perfect. We already have this array ready for us. I'd like to try just sorting it in our next section. We're going to be working with advanced collections beyond arrays, and we'll be able to do a sort manually ourselves, but C# also has that class available for us. So can I say like database dot sort? I think I had to use the array class, array dot sort. And then the database that I would want to sort would be database. So our next section is super exciting. We'll sort manually. And I tell you that when I'm saying, look, but you can use this array.sort and sort automatically, but I'll show you how to sort manually because it's super fun. But this sort statement should sort our database. Our database is full of these different objects. So what's it going to sort them by?
Assuming.
Yeah, let's try it and see. Is it going to give us anything? I've got to make sure that this is my project that's running.
Oh, you're saying what field will it sort
And it won't, right? It's just like, sure. You have this array here of these things that you've created, and how am I supposed to sort it? I don't know what you're talking about. So it doesn't know how to sort patients. This is not something that the array class has ever been taught. It says I know how to sort integers and I know how to sort strings and doubles, but I don't know how to sort these patients that you have created. So let's teach it how. In our class up here, we can implement the IComparable interface. And then as soon as we do that, again, we should get that error. So that's okay. That's what we expect. Not being very helpful at telling me what the error is.
Need a colon,
I got to make it stop running.
comma.
Let me make it stop running and then maybe it will. So it says that you've got this IComparable, but you are missing
Colon
a method.
comma.
Do what?
Colon.
Colon instead of comma. Since I'm not inheriting from any other class,
Okay, you need the compare to.
that look better. Now it's saying you need that compare to method. It doesn't say it straight out, does it? But it says it down here eventually. You don't have compare to. So let's create that method. Now, we're going to return an object from our compare to. Is that right? No, we wanted to return an integer because we are going to return either positive, 0, or negative. I want to do it kind of like they did in the presentation. So let me get back over here. So we'll make this object obj, is what they called it. And then they created a temporary patient. We'll have to do a little bit more, won't we? Because we have our two types. So if our object is a COVID patient, I have to do the COVID patient dot COVID patient. Then I'll create a variable obj as COVID patient dot COVID patient. Well, it's just all mad at me in all sorts of ways, isn't it? So I'm going to go ahead and put a return statement in just to get rid of that error at the top on my compare to method name. Now, if my object is a COVID patient, I should be able to declare my variable as a COVID patient. So now it's happier with me. So now I'll say, well, if it's not a COVID patient, then at this point it must be a maternity patient. Now, when we look at our patients, I'm going to bring up our patient class. Outlining. We didn't really create our patient class with a lot of granularity of our field names, thinking about sorting on down the road or anything like that. So let's just sort by their name. We won't do a lot of fancy things with it. We'll just use that field because that's going to be the best for us. So basically, in our database then, as we continue on, I've got one problem, because my problem is I want this temporary variable to be something that I can use to compare to, and I can't allocate it like this in this if statement, or it's going to be local to that if statement. So I could say maybe just use my patient class and say patient tester dot patient. We need to have a using for that. And then I need a using for my maternity patient, because I just now am trying to use all of those now. So I think maybe instead of worrying about all of these different types of data elements and everything, maybe we can just get away with being a patient and say, oh, well, they're a patient. Oh, I can't do that, can I? Why is that? Can I not instantiate a patient?
Just allowed it.
Right, we just allowed it. We said it's abstract. It's not something that we can do. So we're just going to have to say object temp. And then in our if statement, we'll say temp is a COVID patient, or temp is a maternity patient. Will that work? So we use that system object to say, I'm not sure at this point, but I need this variable declared because I can't wait until I'm in my if statement and declare it, because then it won't be accessible outside of the if statement. So I'll just make it an object. All right, so now my temp variable is either a maternity patient or a COVID patient, and it doesn't really matter to me at this point, because all I want to know is this patient, is this one greater than the last one? This really, is not going to work because this compare to needs to be someplace else. Let's take a look at it here. Tell me where I've gone astray. What I've done is I've created the compare to within our database class. And I said at the very beginning of talking about the compare to method that it takes a current instance of an object and compares it to another instance. Well, I can't do that this way because I've just said that my database is a static object, so I don't have an instance in this case. So it's not going to work in this way. So this is one of those ones where I'm just going to have to take a minute, you guys, and figure out what I've done, because I've got myself worked into a corner. Never happens to you, does it? I had it all set, but then I messed it up. So what we're going to do is take some lab time here. Now, I'll get back to this and show you how to make it work. But before we take some lab time, I want you to think about what kind of interface you can implement in your application. And you can see that if you haven't gone through that chapter yet, you're going to need to take some time to go through those examples and take a look at stuff. For our assignment, it says that you have to implement an interface in your sports team that has to do with budgeting. So we could implement an interface called iBudget, and you could make every different sport implement that interface. That would be fine. That would be one way to do it. Or you could have another type of interface that was a special budgeting item, like, I don't know, budgeting for uniforms, and have only teams that have uniforms that are paid for by the sport participate in, or you could have a cost for the uniform. What we would like to think of the best implementation for an interface is a behavior that only occurs for certain types of teams. So if we do an iBudget, that's a good one. That's an interface, and we can say we want to return that annual budget amount for every single team, and every single team implements our iBudget interface. That's fine. That's a good use for it. But in that case, we could have just put that as an abstract method in our team-based class, right? If we were just going to use it everywhere. So the interface is more something that's a little bit unusual, you know, that isn't quite the same in every single implementation of our class. So we'd like to think of something like that. So something budgeting that would be in effect for certain teams, but not others. Anybody got any ideas? Good ideas. I've seen some really, really good ideas. So let me take about 30 minutes here. What time is it? 8:53. So I'm going to report back to you guys at 9:20 to see if I've been able to figure out what kind of mess I've created here with this compare to, and we'll get it fixed the rest of the way. And in the meantime, should be going through the interface chapter and deciding how you want to add an interface to your application. I have an alarm set just for that. What have I done? I think it'd be real easy to fix. I just don't want you guys to suffer.
Base. Baseball, go. But you can't have this, so you can actually save that. You want to actually add. Another one. Here you could say, interface, call it. Budget. Go back here. Yeah, man, first base. That. Can't do that here. These guys, like, these guys won't allow that. Yes, well, these are carrying the base class. This guy's actually.
more than that, the more you pay off the bank.
So no, so here's what, so right now we're finding. You get
That should be
I'm afraid
this.
Yeah, they're saying.
that's why I'm asking. I understand that. I'm
I'm
a-
assuming you
That's what I'm doing.
that right there.
You have a base class. And I put
Yeah.
See,
Well,
that's what I'm
not
asking, right? Yeah.
two interfaces, right? That's an interface, that's an interface, you can do that.
So-
That's what we're doing.
Will it like?
But that was not
Right there. But you can't do this.
No, that's what he's saying. So this, he's using words instead of the he's using derived class.
That's what I was saying.
These guys automatically get that because they are
I've been
that.
enough where I have, like, the house is in my.
No, I'm trying to see that. The way that I see it was showing it though, it's just using the simple term.
Well, I can name this derived.
But
Good.
what I think they're saying is that is, they're using the term derived because it's really the derived class.
Yeah, which is, these guys are derived the base class.
So wouldn't that be the same thing as if
I just
instead
like
of
being really.
using the base class, I would give you an extended class?
Well, you can't do that, though. Look, you do this.
See, I think that's what he's saying right there, is that you're going to, if you were to add an interface here,
And I'm really struck this.
Look at here, right? Right, I added it to my extended classes, right?
Really savvy.
You cannot do this. You're only
Yeah.
allowed one. It does not allow that. Okay. You can do multiple interfaces, but you can't do the derived class like you want class.
so I'm supposed to be possible, just for trouble. That says it's successful.
Okay. Try this here. This one. Maybe this one. Okay. Okay. You can do that. That's weird.
So we can't do it, I still don't know.
Wait, let's take this off now and see. That's why. Yes.
That is actually not that way, I think you have to add it directly to.
Oh,
So the reference.
let's see, it's under there. This one.
Yeah, I'm with that.
Sure, right? You're right. That's why I use that one. Okay. Go here. I can't remember. What else? Because you've got to be using. Now, here's the correct action.
And then, and you're in class one.
Yeah, because that whole class, right? This. I mean, I was studying medical science, studying the base. My mom. Oh, well, yeah, and I have multiple classes. Okay, so, and I'm multiple classes, so you can have multiple. And you can directly put them on, compare them, basically. Yeah. So the interface is in my base. Right. Since I have this, I can. I know. Okay. And then, so, I didn't know that. So when we do what we got. So. It's the right. I was going to get the other one, though. It's actually part of here. I'm just going to do this. However, well, I just gave you one of those things. She said, everything. I don't know what to do. Yes. So, okay. Okay, well, yeah. Okay, so this, if that's crazy. Okay, so let's try it knock out. Let's try to knock out. So, we got it. Great. Okay, so here's our interfaces in our base solution or base project. So we do this one. So we don't need that. What? These are all static. So pause it. Sure. I know them.
Let's finish this up. I know I'm a little early, but I think that our online people are still with us. Turn that on. Okay, here's what I did. I took everything out of the database class, so let's do that first. So in our database class, I removed that method and the specification for the interface. And I thought a little bit about where should I put that interface specification, because if I want to sort patients, I want to sort them all. I don't really just want to sort maternity patients or just COVID patients. I want to sort them all. So I put it in our patient class. So in our patient class, at the top, oh, thank you, sir. So in our patient class at the top, I added our IComparable interface. And then I added in the compare to method. So in the compare to method, I'm assuming I'm going to have a current patient and I'm going to be passed a secondary patient in as an object. I'm going to take that secondary object and turn it into a patient type. And this one made me pause for a minute because our patient class is set as abstract, so we can't instantiate an instance. So I really was happily, pleased that I was able to do that, because I thought it's not going to let me because it's abstract, but it did let me. So it's not an instantiated instance, but it is an instance that we can use. Now, looking at those two instances of patients then, if the current patient, and I went to admit date for sorting because strings in C# don't sort well, and I didn't want us to get into a really complicated lesson on string sorting. So instead I thought, let's just sort by date, because we've got that other field there. So if our current admit date is greater than the admit date of the object that was passed into us, we're going to return 1, current is greater. Otherwise, if the current is less than, we're going to return -1, current is less than. Otherwise, we're going to return 0. Okay, so that's the code we've added in. In our database class, I still have left in this command to sort our database that it got upset with me for before. And I did make a couple of other changes. Here where you guys had so cleverly suggested to use the minimum value for a date and the maximum value for a date, I added those in for our admit date. So we would have some different dates, because otherwise all of our test data is right now. And remember before with our array.sort database, we canceled. We got a runtime error because the system said it didn't know how to sort those object types. So now we should be able to sort them because we added in that interface.
Go back to the patient.
Sure.
We were heavily typing along.
Oh, and I just changed it on you, huh? You're not that fast? I got it. Let me zoom in a little bit, too. And I did the bad, putting the 1 line of code on the actual if statement, which you know I'm opposed to, but is allowed. So this is a hidden thing, and if you guys can't tell, I don't do good with these hidden things. And the interfaces are something that I don't work with often. So because it's hidden and so much a part of the system, it's something that I really have to struggle with every time we use it. So just by doing these comparisons, I'm able to plug in to that system interface and make that sort work. So there is definitely some, hidden things going on. So our array sort method is programmed in such a way at the system level to say, I have 2 objects. I need to find the compare to method to compare one of these objects to the other so I know how to sort. So that's all we have to do is plug in that part and say, oh, this is how you compare one object to another for me, is by doing it this way. So with our dates now, if everybody's got that in, you should see that your list is sorted by admit date. So our first one that was at the beginning of time sorts to the top, and our last one with the max date of 9999 sorts to the bottom. So we're actually being able to just implement that sort real quickly and easily. So what if I had my own interface that I want to implement? I want to implement an interface that is like for, I don't want to make it too specific to either type of our patients, but let's say for our maternity patients that the hospital likes to always give them a gift when they leave the hospital. And we have other types of patients that they like to do that too. We just don't have those types of patients here in our list. Like kids, you know, patients that are kids, they like to give them a little balloon or some sort of sticker or something when they leave. So let's add an interface for that. So I could put this interface wherever I want. And in my solution right now, I've created a separate project for each different type of component. So let's do that. We wouldn't have to, but right now we don't really have a good logical place to put our interface. So let's create a new project. I'm going to add a new project. And I'm just going to call this a class library. And I'll call it patient interface. Now in my project, I get that class1.cs file automatically created. I'll just delete it. Make sure you're working with your patient interface project. I'm going to try to roll up the rest of them. And now in our patient interface project, we want to add a new item. And the item we want to add is an interface. And remember, it's got that little circle icon, just like in the UML document where it shows that circle is being an interface that's associated with this class. I guess I'll just call this iGift. And I'll say that anything that implements this interface needs to implement a method that returns a string, and we'll call our method gift given. And that's it. Our interface is done. We should put comments, huh? Otherwise the teacher might say no comments. Actually, I would not give you a hard time about not having comments here. It is nice. So right now at this point, all I have to do to implement my interface is put in this method gift given, and it needs to return a string, something about the gift. Now I could have this be more involved. I could have parameters here for what kind of parameters I want to pass, like string, 57, string 49. All of those would have to match exactly with that method implementation in that class. So anything that I specify here in my interface definition would have to match exactly in the class implementation. Okay, so let's say for our patients, it's the maternity patient that gets the gift. So I'm going to go find my maternity patient. And right now, my maternity patient already inherits from my patient. So I can't use the colon to add the interface. I'm going to use a comma. And I'll say, okay, it implements the gift. Now I'm not getting the right error because I'm getting an error that says the type or namespace name IGift could not be found. Are you missing a using directive or an assembly reference? Probably. So let's put in a using. Doesn't like that yet. Better put a reference in, huh? So I'll add my project reference. I wonder if we have to put our interface in our tester. Let's go back to our iGift and see if we can build this project. Build patient interface. It let me build it. So let's check our maternity patient. References. There's my patient interface. So I just hadn't built it. Okay, so my maternity patient then, if I look at my iGift, now I've got a new error. What's this one? It says iGift is inaccessible due to its protection level. What's that mean? Should we Google it?
We're working on that over here. We have the same error. We put public before it and it fixed it.
Well, I always do that too. And you know what we should do? Is we should see what the most restrictive access level we could get away with would be. So right now we're working with things that are in the same solution, but not in the same project. So I'm going to go back to my iGift. Let's try protected. Let's try it. Because, well, first of all, I'm going to try private. And I don't think that's going to work because that's basically where I am now, right? I'm going to rebuild the whole solution and look at my maternity patients. And it doesn't like it. So private is too restrictive. Protected. Build everything. Elements defined in a namespace cannot be explicitly declared as private, protected, protected internal, or private protected. It wants it to be public. Now I'm going to rebuild my whole project again. Rebuild solution. Well, it wouldn't let me do protected, but I do want you to experiment with that at home and try those different access levels so that you feel more comfortable with which ones will work when. Now, my error should finally be that I don't implement the method. Finally, that's the error I was looking for, that I don't have my gift given method. I can handle that one. So I'm going to put that down at the bottom. And because this is in my maternity patient, I really could make that a private method, couldn't I? Because I'm not going to have anybody run this from any other application. So I should be making those more restrictive. I'm going to say that this private method returns a string, and we called it gift given. And it's just going to return, let's see, what do you want to, we'll call it the new mom gift pack. Now I'm going to rebuild everything. Gift given. It says I'm still not implementing it. What's wrong? Is it the private? No. Do I need to override? No. Okay, maternity patient does not implement interface member gift given. Maternity patient is not public. It's complaining about it not being public. Okay, I think then all the errors that I'm down to are my DLL not being found, which would be because of that error. The only way I could get rid of that error was by making this method public. So I'm going to try to build everything again. And then finally, I'm down to no errors. Now, I did all that to implement my interface. My interface has to do with gifts that are given from the hospital. If I have any patient classes that give away a gift, I want that to be named gift given so that I can find it easily in my code, or I could run it from another application. So let's run it from our tester. How do we test that that interface is implemented properly? Well, getting it compiled was a big part of it, right? Is everybody's working okay? No. Okay, let's get them working. Here's what in the mess. He ended up with these 2 lines of code. Okay, so at the top of our maternity patient, we add in our iGift interface. Then at the bottom of our maternity patient, we implement the gift given method. And here's where it just would not cooperate with me until I made it public. So an interface is a little bit different with those access restrictions. Now, is that okay? Is it working? Or at least compiling? Awesome. Okay, so let's update our tester to test that thing. In our patient tester, let's look at our form. We set it up to where whenever somebody clicks on one of our patients, we have that message box that says what type of patient they are. Let's go look at our code for that. So it's in our selected index changed method. We said that if they're a COVID patient, we would do this. Otherwise, we would do the maternity patient message box. So we could add a little bit more. We could say if This one is iGift. I'm going to have to do some importing and things though. Let's check our references. In our forms application, right now we have a reference to our patient, our COVID patient, and our maternity patient. I need to add a reference to that patient interface. We didn't really add any using statements. We just actually fully qualified everything. So let's do that same thing. Patient interface iGift. So if this one is the maternity patient, we can also test it this way, and we can say, is this one using the iGift interface? If so, let's say gift given. And then we want to add the gift given method. Can we find it? So it's not letting me see that method because it doesn't think that our object is that type, but yet whenever we do the if statement, it's able to tell. So we can do some work here. Let's say we're going to set up a COVID patient, or I'm sorry, a maternity patient. We'll just use our patient. I'm changing my mind again. I'm going to comment this out. You guys can just say, say, what's wrong with her today? I don't know. I don't feel good. I'm going to comment this out. And I'm going to go to our database. And in our database, let's just add a little bit more, can we? We've got our interface implemented. How can we test it? That's all we're trying to do here is just test it. There's so many different ways we could do it, and my brain is just not thinking of any good ones today. So how can we test it? We know that that maternity patient has that interface. We can do the if statement. What do you think? I'll just do it. Cheeto. And I'll just say that I'm going to do a message box and say, gift will be given. I have gone back to, I have gone back to our list box, our method that is our selected index changed. And I'm just going to be lazy and say, if it's a iGift interface, a gift will be given. Now, know that we could figure out that call if we wanted to. but I don't want to waste all of our time. So if I run my tester then, if I click on a COVID patient, we should see the COVID patient message. If we click on a maternity patient, we should see the maternity patient message and that our gift will be given. Now, what I want you guys to figure out is, how can we tell them what gift it is? It's not letting me call that method. We should be able to. Okay, so as you can tell, interfaces are not my fave, but they're real easy. It's just that they have so much going on behind the scenes sometimes that we don't know about these system interfaces especially. So one time I was teaching advanced Java and we were working with trying to do an Android phone app, and they had the Android development tool downloaded, and they had gone through a tutorial and everybody was working really hard and it wasn't coming together very well. And they wanted to be able to sort the list box items in this application. And one of the guys came back the next time to class and he was like, "You won't believe it, you won't believe it. I just put in a compare to. I've used IComparable," because we had talked about the interfaces and we had kind of glittered through them a little bit. And then when he actually found a place like that to implement it, it was like, ah, now we see how all of this kind of comes together. So interfaces are one of those things that you could work in a shop for 20 years and never see one, and that would be okay because it wouldn't be like the end of the world. Or you could work in a shop that uses them all the time, and every time you turn around, there's another one that you need to be working with. So where I want you is, I want you to understand that an interface is a bunch of method declarations, abstract methods, that have to be implemented by the class that uses the interface. And as long as you've got those basic rules down, you're in pretty good shape with the interfaces because it is pretty advanced topic. So I do like the way we can sort things out easily. Everything's there. Any questions? Lots of questions? Kind of, this one will become clearer as you look through the textbook.
Isaac has a question.
Yes, sir. What's your question, Isaac? Okay. We should be able to hear you, I think. Not quite. I don't know why we can't. Does it automatically run when the class is initiated? No, when it ran when in our database class, when we do this array.sort, the sort system method calls that compare to method. So it was by implementing the system sort, made that compare to get called. So it's kind of hidden. Other questions? Let me close this thing then.